Okay, sir.
That's why I've taken the right from you now. Okay, let me approve. So you send me the first. Okay, so hello class, are you there?
Yes.
Let me see if the right.
Yes, sir.
Yes, sir.
Can you see? Can you see whatever
Yes, sir.
being written?
Yes, sir.
Yes, please.
Okay,
Yes, please.
okay. Then we can take off. Okay, so we were just trying to derive the equations of vertical motion. So the first one, V equals U minus J T. Then the second one, H equals UT minus half JT squared. And then the last one will be V squared equals U squared minus 2JH. These are the three equations of vertically upward motion. There are three equations for vertically upward motion. So if you want to calculate the velocity after any time t, you can use equation 1, you can use equation 2. If you want to calculate the vertical height reached after any time t, you can also use equation 2. All right.
Okay.
Gideon, I'm listening. Yes. Gideon, your line is not good at all. Send your question to me, okay, on WhatsApp. Okay. All right. Now, when the body gets to the maximum height, when the particle or body, the particle reaches the maximum height, what happens? Class, at the maximum height, what happens? Class, at the maximum height, what will happen? Gideon. Oh, Augustine, how did I get the equation? You see, this equation is just similar to the first ones we've learned. Linear motion, these were the three equations we had. These were the three equations we had for linear motion. And so these equations were derived from this one. Augustine, are you okay? Augustine, are you okay? So
Yes, please.
we just derived it from this one. The only thing which changes is that, you see, on linear motion, in the case of vertically upward motion, the body goes up and its speed reduces, and so the body decelerates. The reason why you see negative, and this deceleration is caused by gravity. hence changing A to G. Okay. So at the maximum height, you said what happens? Class, what happens at the maximum? Hey, Frank and Co, at the maximum height, what happens? Emelda,
Yes, sir.
can you hear me, class?
Yes, sir.
I said at the maximum height, what happens? Giovanni?
The acceleration is 0.
No, acceleration is
Body
not.
decelerates.
When the body reaches the maximum height, what happens?
So it falls back down.
That's to decelerate.
It starts to decelerate, it falls back. Okay, let me give you a scenario. If you hit a football or you throw a volleyball, whatever ball, to go up, the ball cannot be in the air forever. It will surely come down. This is due because of gravity. Gravity wrestles with the force and then reduces the speed with which it the body or the ball goes upward, and so decreases the speed with time. When the body just begins to return back to where it was thrown or to the earth, okay, it means when it is returning, then it means it has moved up and has gotten to the maximum height. So if it was thrown from here, and then it could reach the top of a story building. At this point, this is the maximum height it could go from where it is thrown to where it's reached. This is the maximum height. Now, at the maximum height, the ball would attempt or start coming down. Why is it coming down? It is coming down because at this particular height we are calling as the maximum height, it has no speed again. So it's similar to you running and then being so tired and decide to just sit down or just stand and then just be breathing. You are not moving again because you are tired. Your velocity is 0 as at the moment you stop. So at the maximum height, the final velocity of the body or the velocity of the body is 0. Are we okay?
No, sir.
When a body goes up, wherever it could reach, okay, it will start coming down, isn't it? If it could reach this point, and then from there it starts to come down, it means from the ground to where it's reached, that's the maximum height the body reached. At the maximum height, it is coming down because the velocity of the body at that height is 0. And so we say that at the maximum height, final velocity is 0. Final velocity is 0. The reason why it cannot go up again, but it's coming down. Marilyn, is that okay?
Yes, please.
So at V, maximum height V is equal to 0. That is how come its initial velocity U cannot be 0 because it must go up. But its final velocity will be 0, and it will be 0 at the point where it is been able to travel to the maximum height. Any question?
Sir, please, what of when it's coming down?
We'll look at downward motion afterwards. This is for upward motion. Okay.
Okay.
So if At the maximum height, V is 0. Then we can use equation 1 to derive a very beautiful equation. Using equation 1, V is equal to U minus GT. At the maximum height, V is 0. So we equate 0 to V. This is equal to U minus GT. Can somebody help me make T the subject from what we have? Gideon.
Yes. Let's go to the answer or the step.
Just help me make T the subject.
Okay, so we take move to the other side, making a new equation of minus t equals to minus g. And we divide both sides by negative g. If you go u into g, if you go to the final answer for u over g.
So U will be equal to, T will be equal to U over G. Yes. What this simple equation actually means is that if a body is thrown vertically upwards and then gets to its maximum height, the time taken to reach the maximum height is equal to dividing its initial velocity. So time taken to reach the maximum height. Maximum height is equal to, that is T. This is equal to its initial velocity divided by acceleration due to gravity. Due to gravity. So if you are asked to calculate for the time taken to reach a maximum height, just divide the initial velocity by acceleration due to gravity, and you will be smiling to the bank. Okay.
Okay.
So this is one of the standard equations to use in vertically upward motion. Then we want to also calculate or have an expression for the maximum height it could reach. The maximum height the objects can possibly reach. Please, I'm coming in. A minute. Attendance today is poor because of March pass. So parents often use the attendance dropped on the platform to check on the awards. That is why I frequently do this. Okay. Meaning if you don't come, you'll be questioned. Where were you? Okay, so we have a relation to determine the time it takes the body to reach a certain maximum height. Okay. Now we are interested in determining the maximum height it could reach with a particular initial speed. So when Mr. Abia gives a body maybe 10 meters per second initial velocity, Imelda can give the same body half meter per second. Okay, so when I give it that initial velocity and Imelda gives it that initial velocity, what possible vertical height can the same mass travel? That is the next equation we are looking at. Okay, so using equation 3, though we can use both equation 2 and 3, but let's use equation 3. V squared is equal to U squared minus 2GH. The body is at the maximum height. So at maximum height, we know V is equal to 0. So if V is 0, then 0 squared is the same 0. The value is the same. Hello? Please, can you hear me? Class, can you hear me? Hello, class. Gerard, can you hear me? Anna? Oh, hello?
Hi.
Class, can you hear me? Elikem?
Yes, we can.
Yes, please.
I had, yes, intermittent break. All right. Today's network, yeah, we have nothing to say. We don't control it, so we just must make use of it when it is okay. All right, so using equation, let me see if it's still recording. All right, using V squared is equal to U squared minus 2GH. When it reaches the maximum height, at maximum height, V is equal to 0. So 0 squared, the value is the same. It's equal to U squared minus 2GH. 0 squared is still 0. So we have this. Elikem, from this equation, help me make H the subject. Elikem, are you there?
Yes, sir.
Help me make H the subject.
Sir, please, H is equal to U squared over 2G.
So H is U squared over 2G. And this is a very important standard equation. And that is the equation to determine the maximum height rate. Also,
Sir, please, isn't it minus 2G?
no. To make H the subject, you have to take minus 2H to the other side of the equation, and it will be positive.
Okay.
So maximum height reached, meaning that if you want to, when a body is thrown upwards and you want to calculate for the maximum vertical height, it is equal to the square of the initial velocity divided by 2 times acceleration due to gravity. So the example I cited, I projected a body upwards and I gave it a velocity 10 meters per second. Imelda also tried, because she's not strong as the metal man, Mr. Ibia, she's able to give only 3. Give it a speed of 3 meters per second. Imelda, are you here?
Yes, sir.
Okay. I said you are not strong. So, we want to calculate the vertical height in both cases the object could reach. Mine will be 10 squared divided by 2 times acceleration due to gravity is approximately 10. So we have 10 by 10, which is 10 squared, divided by 2 by 10. 10 cancels one of them, and 2 into this 5. So the vertical height, when I give the object initial velocity of 10 meters per second, will be 5 meters. Let's calculate that of Imelda. Imelda gave it 3. So her maximum vertical height range will be 3 squared divided by 2 times 10. This is 9 on 2, 20. On 20. And what is 9 over 20?
0.45.
Again,
0.45.
so that will be
0.4.
0.45
45.
meters. Not even up to 1 meter. Okay. So this is the expression for the maximum vertical height the body could reach when it is projected upwards. We can also derive this equation using equation 3. And equation 3 is H is equal to UT minus half JT squared. We can derive the same equation by using equation 2 rather. This is equation 2. Now, what is the expression that was obtained for the time taken to reach the maximum height? What formula did we make for the time taken to reach the maximum height? Yes, I'm listening. What formula was obtained for the time taken to reach the maximum height?
Over G.
T is equal to U over G.
So T is equal to U over G. Substitute T into this equation. So we have H equals U times U over G minus half times G times U over G all squared. So let's take our time to simplify. We have U squared over G minus half times, oh, there's also G, times G times, we square whatever is within the bracket. So we have U squared over J squared. By J squared, I want to make a J times J. This J would cancel one of them. So finally we have U squared over G minus half times U squared over G. In fact, we can factorize out U squared over G. So we have H is equal to U squared over G times 1 minus half. What is 1 minus half?
Half.
Half.
This is times half. So multiply numerator, U squared, multiply denominator, 2G. We have the same formula as we use equation 3 to derive. So you can derive this using equation 3 or equation 2. And that is, so H is the maximum height reached. Any question? Any question? So this is for vertically upward motion. All that is done is for vertically upward motion. We are going to derive that for vertically downward motion. But we have about 8 minutes to end the show. So vertically upward. When an object is thrown to go up, vertically upward motion. All that is involved. Calculate the time, calculate the maximum height reached, and all that. Let's do something for vertically downward. For vertically downward motion, downward motion. But do you know, class, do you know that when an object is dropped from a height, as the object comes down, its speed would be increasing? Do we know that?
Yes.
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 As the object drops to the ground, its speed will be increasing, meaning that by the time the body drops to the ground, it is hitting the ground with that maximum velocity. And so whenever you are on a particular height, you need to be very, very careful so you don't fall, especially if you are descending down a staircase. You must be very careful, because if your leg gets displaced and you are rolling, you roll and hit on the ground with a certain maximum velocity, and it is very, very injurious. So we must be careful. The boys, some of you are fond of climbing a object. Okay, be very, very careful, because when you fall, you are always falling and you hit the ground with that maximum velocity. So in vertically downward motion, example, we have an orange hanging down here, okay, on a tree. At this position of the orange, the initial velocity, can somebody tell me about the initial velocity of the orange at that height?
So this is when it's falling down.
No, it's on the stalk. The orange is on the stalk.
Zero.
That is 0. Why will it be 0? Why do you think that will be 0?
Look at the velocity of upward motion at the maximum height, the velocity there. Also, the initial velocity, okay,
Gideon, well said. Anikem, let's hear from you too.
Please, that's what I was going to say.
Priscilla, let's hear from you.
Because there is no force acting on it.
Priscilla, there is force of gravity acting on it. Initial velocity is 0 because at this point the body seems to be at rest. Okay, it's because it's at rest. Now when this connection between the orange and then the stalk breaks, force of gravity will then act on it and causing the downward motion of the object. But when it's on the stalk, the initial velocity is 0 because the body seems to be at rest. When there is no force, there is force, but because of this, it produces another force which counters the force of gravity. So there is a force within the stalk which balances force of gravity. So the net force at that position is equal to 0. When the net force is 0, the body is at rest. Now, when the force within the stalk is weaker and is defeated by the force of gravity, then this time around, there is a net force. The difference between the force which was holding it and the force of gravity acting on it. When the net force is not equal to 0, for every body or any body, when the net force is not equal to 0, the body accelerates. So it means that there is no acceleration when net force is 0. When net force is not equal to 0, bodies then begins to accelerate. Okay, and this acceleration is due to gravity. So initial velocity is 0 because the net force acting on the body is 0. At this position of the body, we say that in physics, the body is in equilibrium. So when net force acting on a body is 0, body is said to be in equilibrium. Body is said to be in equilibrium when we begin dynamics and then we look at Newton's laws. You will understand this properly. Class, is that okay?
Yes, sir.
So it's exactly 12 o'clock by my watch. This is where we'll draw the curtains on today's meeting. Continue to enjoy your holidays, but you owe me first assignment and I'll add on. Gideon. Gideon, I can't hear you, unfortunately. Gideon, test it to me. Class, if you have any question, test it to me and I'll address it for you. Okay. Bye-bye. Continue to enjoy your holiday. Hey, no, Omega continues, so you can rest until maybe tomorrow. Continue to enjoy your studies.
Okay, sir.
All right.
Bye.
Bye-bye.
Bye bye.
Goodbye.
Bye-bye.